Hello everyone. Today we talk about generating of live images. The reasons why we want to do it. First of all, to check how it works, if it's suitable for hardware, to restore broken operating system or to install new one, and why not to use existing images. There are also a few reasons. For example, if you use a custom keyboard layout, it will be quite a tedious task to set this layout few times in a row if you reboot between installation phases or something else, or if you check if system repaired and reboot, and again you need to configure it every time you boot your live image of operating system. Other customizations, maybe you need some additional services, or maybe you need a custom configuration of window manager, and so on. And of course, sometimes you need some additional files that have to be present on this on the same media where your operating system. And today's talk will be consisting of 3 parts. We will get the tools, we'll generate a sample image. After that, we will explore the possibilities of customization of such image, and we'll do some practice and we'll generate some very custom image with all necessary stuff. Hello guys, hello Rostislav, hello Miniken. Actually, sometimes I think it will be cool to call people by name, but it will be hard to other people to track which comments I respond to. So I will be using nicknames that you use on YouTube accounts. Okay, first of all, the tool we will be using for generating images is a Guix. For people who are not familiar with it yet, it's a package manager, functional package manager, and today we won't cover in details what it is precisely, but you can learn it from documentation or from other streams on my channel or maybe some other channels. I will describe few properties that are important in my opinion, and the reason why I picked it as a tool. First of all, I picked it because I develop some stuff for Guix, and it's a quite obvious choice for me. But in general sense, Guix allows to make a declarative description of operating system, and after that generate an image from this definition. And it is quite cool because we don't need to make manual steps, imperative steps like it's done in some other approach to generate image. We don't need to issue some commands to install some things and after that create layers of file system and so on. We just declare what we need in one text file, and after issuing one command we get the resulting image that we can burn on any media, maybe disk or USB stick or anything else, and boot from it. Also, it's reproducible. If we have a channel version, exact commit, we can get the same image every time we issue the command. It doesn't matter if something changed on some remote servers, or it's a different year, or maybe even different century. We will be able to get the same result every time. Also, it's quite simple. We just define our operating systems that we want, writing a command and getting the image. Quite simple and obvious way to accomplish the task. And also availability. Currently Guix is available in Debian and in almost all derivatives from Debian. That means that we can get our tool just in a few commands. First command is installation of the package, and the second is updating the channels. Here you can see the example for Debian. You just need to launch those two commands. First one will install Guix, and the second one will update channels for Guix. Pretty simple so far. For different distributions like Fedora or maybe Nixos or something else, it can be a little trickier, but if you're interested enough in this topic, you will accomplish it on any distribution that supported by Guix. If you're not so interested, you can just use some Debian derivative or maybe Guix system to do this task. Okay, we understood the reasons, I hope, understood the reasons for picking Guix for this task, and also we now know how to get it. Let's get the first image. The simple command, which consists from few statements or maybe words. Simple enough. It says that we need to generate a system image in format of ISO, and the definition of operating system we take from GNU system install module, and the variable will be called installation ops. I will explain it a little later, but for now we will just launch this command. It will take some time on your machine, and it will show much more output than my terminal here, but it is because you will be building it for first time, and I already built it, and so the result is cached, and it doesn't build it one more time. I got the image, and this image, oops, (600 megabytes), and let's try to run our image in virtual machine to check if it works. For this I will be using QEMU. I need nix-shell QEMU. This command allows me to access QEMU binary even if it's not installed in my system, and I will be using this command but with our image. What it basically do, it just launches a virtual machine and uses our image as a boot device. So you can see on the right part of my screen that operating system is booting and something happening here. I will explain in more details the parts of this command. Enable KVM allows to make our virtual machine use some special kernel models that allows to utilize our hardware much better and to make the virtual machine much snappier and to work much faster. But for it you need to be in KVM group. You can check it with groups command. Let me launch the terminal. Groups. It says that I'm in KVM group, and your user have to be in this group too to use this option. If it doesn't, you just remove this option and it will work, but a little slower. As we can see here, it launched installer, which is provided in default Guix installation image, but I don't want to use this installer, so I will switch to the second TTI. To switch to the second TTI, we need to to go to compat monitor and type command send key Control Alt F3 for example. And now I see that this is an installation image of GNU system. Welcome. Press enter for login. And now I have a root shell, and now I can launch all the commands that I want from here. Quite good. We got the image just in a 3 commands, and first 2 of them was just getting the Guix itself, and the third one was generating image. Hi Grigory. The question from Philip, which programs allows to have completion in my terminal, like this gray stuff here. It's called ZSH autosuggest. It emulates the functionality of fish shell in ZSH. Okay, going back to the topic, we generated our image, we started a virtual machine and checked if it works. Now let's try to make it a little more custom and to suit our needs. And let's explore what's inside installation OS and why we use this strange notation here. To get the content of GNU system install model, we can check the directory in tilde/.config/guix/current blah blah blah, probably share guile site blah 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 Guix, and here we can find this file. It's a local checkout which appears when you do Guix pull, and here you see the version of Guix which was pulled by Guix pull, and we can find probably a little different directory, but anyway, somewhere in .config/guix you can find the source code for this model, but we will get a local checkout of Guix. I put it in work GNU Guix directory, and I will open it. We can see the remote. Actually, let me do this task in a different Emacs window. I already have Majid interface here. We can see that remote for this repository is git savanna gnu org/git/guix-git, and from here you can copy the source code of Guix. I already did it, and it's already on my local file system in work GNU Guix directory. And here I will open GNU system install scm file. This is models which contains installation OS variable that we used for generating our image. I will answer the questions from the chat. And after that we will go back to the topic. Miniken says you can also just choose language after that, if I recall correctly. It will ask you what type of installation you want. There you can choose shell based, and it will take you to the same prompt. Cool, nice to know. Actually, I didn't use the installer. I'm quite skeptical about it because it fails often and people reporting that Guix doesn't work, blah blah blah. That is why I prefer to install it manually and to advise people to also install the systems manually based on Guix manual. But it's not really related to the topic of generating an ISO image, but nice to know for many people, I think. And Philip asks to write the name of the plugin for ZSH. It's ZSH after suggest, I think. Okay, going back to the topic, we're exploring GNU system install model, and we need to go to installation OS definition, and here we see the definition of operating system. In the comment we see that this operating system used on installation images for USB sticks, etc. Yep, and we used this definition for generating our image too. We see that there are a lot of fields defined inside operating system record. The operating system record contains many different fields, which may be not so interesting for us, but let's scroll through them and explain. Hostname is obvious, time zone, locale, self-explanatory. Bootloader, we will use grub bootloader here by default, but it's not important when we're generating ISO image. It's probably will overwrite it with some value to make this ISO image bootable, and it will use grub. Label is something that we will see during the boot before we will log into our TTI. Some kernel arguments which will be passed on the boot, and file systems. File system is something that a little important for us. First of all is root file system, and the second one is tmp file system, which is here for some reason, which you can find here, and some additional pseudo file systems that is also necessary for operating system to boot. You can find them in another model called GNU system file systems. Here you can find the definition somewhere here, for example, right here. Yep. And if you're interested in it, just look and explore it. And of course we will need to set an account that we can use for login, but as we will see later, we also define TTI with after login as a root, which will be used in most cases on LiveCD. But our final image will contain a user with a password, which we will use instead of root account. Yep, maybe it's ZSH after suggestions. Issue is a message that will appear in TTI screen before login. Actually, I don't know the difference between label and issue. Maybe I will explore it later. Let's check what issue value is. Yeah, probably the issue what appears before login prompt and label as something else, but very similar. And most important part is services, which defined in installation services variable. And less important but also interesting is packages field, which contains the packages that will be available in your live image. Nothing fancy here, just a list of packages which concatenated from 3 list of some specific packages and 2 lists of packages which defined somewhere in GNU source code. Not very interesting, but you can find it using grep or just exploring GNU system models. What is really interesting is services, and let's take a look at the value of installation services. And here we can see that here we define message of the day, define a normal TTI, which is a min-getty service, which has after login set to root user, and it will require to press and enter to get user logged in. Also here we define a barebone auth, and it just loads a template file which has another operating system definition, and we do it to have some garbage collector roots present, which will help to persist some packages and other stuff in the GNU store of live image. What else interesting here? First, TTI will have installer program. In my custom image that I will create today, we won't be using it because I don't need installer program in it. On the second TTI we will have documentation in info format that you can read and explore during the installation process if you need. Normal TTIs, which will allow to log in as root some default services, Guix service itself, which will allow to use Guix CLI command and build all the stuff. Some UDF rules, which will be obtained from LVM packages and CRDA package to make command like crypt setup and other work correctly. Co-store is actually important service, especially for when you install in Guix. It allows to start what called store service by typing something like herd start co-store /mnt and pass the root folder where you mounted a partition where you plan to install your operating system, and it will allow to use mnt GNU store instead of GNU store. So everything that you build during installation will be persisted in your store instead of placing it in TMPFS of your live image. But it's more important for installing Guix, not for the live image itself. And some configuration for TTIs, GPM service for mouse inside your TTIs, OpenSSH in case you want to access your live system from remote host, and other services that is also required in some cases, network services and so on. Blah blah blah, network services, dbus, and the last one, GC root, the last one, which is really interesting, which allows to save some stuff in GNU store of our live image, and not to build it again when we will boot from live image if it, for example, doesn't have internet, which we will use to accomplish one interesting trick today. And I think that's all about interesting parts of installation services. Now what we want, we can just take this file and edit it, and after we edit it, changed some services and all that stuff. For example, I don't know, let's break something here and see if it will will be observable when we will launch this command. Guix system build. It should be quite fast because I already built almost the same image. Actually, those two commands are very similar, but the second one uses the file on our local file system, and this file ends, yep, it's already built, ends with installation os. That means that the value of this variable will be passed to Guix build command, and those commands will be equal. But the good part about this command, we can update the content of install SCM file as we want and get a slightly different or customized image. And here we also can update installation os variable somehow, but it will be very hard to accomplish because we will need to do it in one line here using some scheme procedures to modify this variable value. And here we just edit a text file and get a different installation os content. Okay, what we done here, we built the system, and from this system we can build an image. Guix system image minus t. I saw something like that. And as you can see here, we got absolutely the same image with the same hash, and almost instantly. That means that nothing changed between our two commands, and the value of installation os is the same. Now we will edit install SCM file, and for example, I don't know, let's change it to guest, and that's it, and let's rebuild the image. While it's building, type your questions or some funny comments that we can spend our time productively. By the way, I think that it will take a lot of time to generate image during translation because I already streaming and it takes a lot of CPU. So I will probably kill this process not to spend the CPU and the time of the viewers, and we will just try to believe that it works, and the TTI will be logging in as our as guests, and we'll go to more interesting part where we generate much more custom image using tooling that provided by RD project. Okay, I will kill this process now. We explored the installation OS content, and now we will be customizing the image. One of the reasons why people want to customize image is to have a different kernel. Especially it is the reason for Guix user who has a software hardware which doesn't support free software, for example Wi-Fi adapters or something else. In this case you can use a custom channel which has a kernel, vanilla kernel, and you can pass this kernel to operating system record and build a live image with kernel which supports your Wi-Fi card and so on, and you will be able to use it from live image and proceed the installation with internet and all other useful stuff that we expect from operating system. The other solution is to buy a hardware which supports free software, which is actually a good solution, but some people doesn't have possibility to do it, but it's a nice option. Hello Adolfo, and here at the end of the notes for today's streams I have a link to System Crafters repository, and David Wilson already wrote a script for generating custom images which contains a custom kernel from non-Guix repository, actually vanilla kernel, not Libre, as it provided by default in Guix. And if you just really need a custom kernel, you can use his pre-built image, but I don't advise to do it. I advise to solve the issue with this hardware in a way when you change this hardware to something more free software friendly. Okay, the second part is building image with RD. For people who are not familiar with the project, it's just a tool on top of Guix system and Guix home, which allows to configure both, to generate both operating system and home environment from a list of features. You define a list of features that you want, and it automatically creates all necessary system services, home services, and sets all necessary fields of operating system record and of home environment. You also can learn about it from my previous streams, and I think in next 1 or 2 months I will create a good documentation for it, but now there are not so much information in RD repository about it, but I already use it as my daily driver for my configuration, and we can take a look how it looks. Here I define the features for my user, information about my user, about my GPG key, my mail accounts and mailing lists, keyboard layout, and that's it about specific for my user features. And in main features I have much more features like terminal, pipewire, fonts, Docker, desktop and base services, Sway configuration, my terminal and utilities for terminal, and some other stuff. All Emacs related configurations is also provided by all those features, which starts with feature Emacs, and so on. It's quite close to vanilla Emacs experience, but still quite customized configuration, and some other stuff related to torrents, emails, and other stuff. Okay, having these features, I can get a list of system and home services and generate operating system and home environment. And now I want to generate an image which will contain the stuff defined in these features, and to make the environment of LiveCD more comfortable for me, what I will do, I will define a live config which will contain all the features defined earlier, specific for my user, all features like Emacs, email related, and others, and some specific features for LiveCD. I will be using feature hide API to set the font which a little bigger than usual. To make it looks better on my laptop, and also to distinguish this image from what is generated by default. Let's start again the operating system from the image. Oh, okay. Probably I know what label was. What labeled field in operating system definition was. It is the name for entry in grab bootloader that you see here, GNU Guix installation 1.3.0 and some commit. And now when we will boot this operating system, we will see that font is quite small, and on our other image it will be much bigger, and we will be able to distinguish those two images just by the font size. Okay, custom services, I will explain what defined here later, but for now let's just generate this custom image. Actually, the idea of the stream appeared in my mind because because of two reasons. First of all, I wanted to provide people with the image which contains graphical environment for installing Guix operating system. And the second one is to make a LiveCD image for RD project, so people can try the configuration that I create in RD project without installing it. So the two goals which can be accomplished in one move, pretty cool. And actually I already succeed with generating this image, but I will do it right now one more time. Here we define the live OS, which takes operating system definition from this list of feature defined in live-config here. And to build it, I will be using a make file with a very simple command, Guix system image and the path to the config file. And also I provide two environment variables. The first one allows to return an appropriate value here. When I set RD target to live system, it will return live OS. And and the second one is Guile load path, which allows to use not yet committed stuff from RD repository. And actually we can probably live without it, because all the custom stuff is defined in configs as same for now. But okay, it doesn't matter too much. And let's run this command. While it building, I will explain the trick. Actually, two tricks that I used here. First trick is defining an etc service type. This service type can be extended by pairs, actually by a list of lists, and each nested list contains a pair of file name and file-like object, and it puts those file-like objects to etc directory of the final system. And what I do here, I have live channels file in the same directory where the configuration is, which contain this stuff. I will explain it a little later. And it also the service is also extended with Guix sources, which is a directory containing the source code of Guix, and also RD sources is a directory containing the source code of RD project. And when I define this service, during the build time, it will take the content of these files, will put them into the image, and after I boot this live image, I will get those directories inside etc directory. And the second trick is defining a GC root, which will allow to persist all the stuff which is required for all objects which specified here to be present in the GNU store of the resulting image. And here I define XCHE, which stands for home environment, which I use for everyday life. And it allows to store all the stuff necessary for building home environment in GNU store of resulting image. That means that I probably can generate my whole home environment on live image without even access to the internet, because everything will be in the GNU store already. Miniken asks, but the path being hard-coded is a problem for others to try out username, isn't it? Yes, kind of, but I don't save this thing as it is. It just a work in progress stuff. Here probably I will be using, instead of local file, something like git reference, so it will take the content of Guix sources not from my local file but from remote repository. But it's not that important. I just showing the example of how we can do it. And after the image built, it doesn't matter what was here because it's already in GNU store, and etc Guix sources will be pointing to GNU store in live image. That's mean that your question is right. People who will try to copy paste this code will probably have some problems with passes while building the image, but it's just an example. And the resulting image will not depend on the content here, because when it built everything inside image already. Probably the final result will be much more polished and doesn't contain those absolute passes to the repositories, and will have references to Git repositories. The trick that I used here requires to be this object to be lowerable. That means that we have to define what is called Guix compiler, and let me open the file called home.scm. It's a file inside Guix repository in GNU home model. And here at the end of the file I added a Guix compiler definition, which allows me to use home environments as GC root. GC root requires each object passed to it to be lowerable, and this Guix compiler allows to make home environment lowerable. I will upstream this change a little later via patch, and for now it won't work if you will try to register home environment as GC root. But when this change will be upstreamed, you will be able to do it easily. Actually, it's something new that I learned today, that how we make some records to be serializable in G expressions. Okay, it's again takes a lot of time to generate image. For this, I already have an image, and I even already booted. And moreover, I already did a Guix pull on local etc channels, and as you can see here, the font size is quite different. Let me go to the TTI, and you can see here the font here and font here very different. It's much bigger and a little prettier. And if we take a look at etc directory, it's image generated from the file I showed here using the command defined in makefile. I just don't want to wait while it finishes, and I show you the resulting image that I generated before the stream. Here in etc directory we see Guix sources, and if we sources, and if we add a special flag, we will see that it points to etc static Guix sources, and it contains the stuff which exists in my local Guix repository, local checkout of Guix repository. That means that I can do a very neat trick. I can take a look at the content of channels SCM. And channels SCM has a definition of two channels, Guix channel and RD channel, and they both points to my local repositories in etc directory. And that means I can do Guix pool -c etc channels SCM and build a new Guix version from those two channels. And after that, for example, I will be able to find packages from my RD channel, but before that I need to do hash Guix, I suppose. Yep. And you can see that there's a package defined in RD packages, and previously it wasn't available before I hashed Guix binary. It is because we used the Guix provided by installation image, and after I did a Guix pool, I generated a new Guix binary from the source code of Guix and RDE channels, and now all the stuff defined in those channels is available for me. And also, if you will take a look at GNU store directory, we will see that it contains a lot of different stuff. And what is more important, it contains, for example, Emacs configure packages, which is what generated by my RD configuration for home environment. So that means that everything that I use on my local machine is already present in the GNU store of the live image, and I can build my home environment without even accessing internet, I hope. Let's check it. For that we will do Guix. Okay, we already obtained those channels, so we can type Guix home build etc rd sources rd examples abcdw configs scm, and here we need to say xconfig xe home, I think. I don't, yeah, xe home, and feature Emacs org agenda unbound variable. Okay, this error appears because I have uncommitted changes. So I need to do one more trick. Guile load pass equal to etc. Okay, and now it's a little strange. etc rd sources. Looks good to me, but maybe it doesn't like symbolic links. Will it work? No. For some reason it fails, and it's clear why it fails. Because I have uncommitted changes related to feature Emacs org agenda, and it complains about it. Let's try to get Emacs next pgtk latest. Actually, it should be built, and it should work without substitutes, because all the stuff should be available in the GNU store, but for some reason it's accessing substitutes. But let's see if it will be building Emacs itself. Probably not. Today's stream is a little boring because I do some stuff and wait until it's finished. For people who is watching just to get information about generating a custom image, you probably need only a few first minutes of the stream and you don't have to watch until the end of the stream. Not boring at all. Thank you. For some reason it says that nobody watches me, but it's for sure not the truth. The dashboard kinda strange in YouTube. Okay. The build process inside our virtual machine is quite slow, and I probably don't want to wait until it finishes because it will take a lot of time. We was able to make sure that everything defined in etc service came to our final live image. We was able to see that GNU store is populated with the stuff which is generated for our home environment, because without this stuff we won't see anything related to our home environment. And for example, configuration for Emacs packages is generated only for home environment. That means it works. What else we want and need to do in the future? We need to implement a system service which allows to specify for a user a home environment. It will help to prevent the hack that we use today with GC root service type. We just will specify a home environment for a specific user and will build the image, and this home environment will be automatically instantiated for this user without any additional steps like we do right now, like building home environment with such a strange command. And we will be able to boot to the live image with all the stuff pre-configured, not only the system stuff, but also stuff for the user, like window manager, Emacs configuration, and so on. And after I finish with this system service, I will be able to produce live images which will have everything pre-configured. I will define some probably I will make TTIs to do after login, so you don't need to know the user name and password, and everyone will be able to test the configuration I use on some virtual machine on or real hardware. And I think it will be pretty cool. That's about future work. And as a conclusion, we saw that generating images is not a really hard task. It's just one command and two more commands to install Guix itself. And if you want to tweak the configuration, you just need to get the Guix source code by by any way you want, copying from local checkout created by Guix pool, or using git clone and copy from remote repository, editing the definition of operating system, and generating image. That's it. And it's very interesting how the good tool like Guix allows to make such a complicated task relatively simple. Probably it's not the easiest way to produce live image of operating system, but it's simple for sure. We just define an operating system record and generate image from it. If we want to change something, we don't need to repeat all the process. We just change the definition and issue one command. In more imperative ways to generate images, we will need to issue all the commands in the list, like generating base image, generating additional layers, and so on, and to redo the separation every time. But thanks to declarative nature of the Guix, we just asks what we need from operating system and generates image. And I think that's it for today that I wanted to tell you. It's a little unfortunate that I have not finished preparing a complete live image with graphical environment, but it will be a task for the future, and probably later I will show you the good LiveCD for Guix operating system with all the stuff predefined and with a fancy and clean Emacs configuration. Thank you everyone for your attention, and see you in a bit. Bye.